Welcome to itvisiongh Enterprises Solution to Past Question in BECE Mathematics. Session B, Written, Year 2000. Question number 2. itvisiongh 2020. I am Lawrence Danso-Amoako, alias Kapiri Impulse. I am going to be your facilitator.
BECE 2000, Section B, Question 2. The question is made up of two sub-questions, 2A and 2B. I will read through the questions and pause along for their solutions. 2A. In the diagram, P, AD, Q, and R, B, C, S, are parallel lines. BD equals to DC, angle ADB equals to 65 degrees, and angle ABR equals to 50 degrees. 2A sub-question I. Calculate the angle BDC. I will pause for the solution to 2A sub-question I.
2A, we have been given diagram 1. The line BADQ is parallel to line RBCS, and magnitude of BD equals magnitude of DC. Angle ADB equals 55 degrees and angle ABR equals 50 degrees. Our task I is to calculate the angle BDC. I calculate the angle ABD. I find the angle BAD. IV, identify triangle ABD. 2A sub-question I, we have to calculate the angle BDC. That is the angle over here. But we know that angle ADB should be equal to angle DBC and should be equal to 65 degrees. The reason being that they are alternate angles. That is the angle over here equal to the angle over here because they are alternate angles. We have also been given that the magnitude of BD equals magnitude of DC. That this equals this. And therefore, it implies that triangle BCD is an isosceles triangle. Since triangle BCD is an isosceles triangle, it means their base angles are equal. So the angle here is as well 65 degrees. That is angle DBC equals angle DCB as the base angles of an isosceles triangle. Now, from triangle BCD, 65 degrees plus 65 degrees plus angle BDC should be equal to 180 degrees. This is because the sum of angles in triangle BCD should add up to 180. Therefore, 130 degrees plus angle BDC should be equal to 180 degrees, or angle BDC equals 180 degrees minus 130 degrees, which equals to 50 degrees. So, angle BDC DC equals 50 degrees. That is the solution to a sub-question I.
2a sub-question I. Calculate angle ABD. I will pause for the solution to 2a sub-question I.
2a sub-question II. We are to calculate the angle ABD. That is the angle over here. But we know that the sum of angles on a straight line should add up to 180 degrees. Therefore, 50 degrees plus angle ABD plus 65 degrees, this plus this plus this should equal to 180 degrees, or angle ABD 65 plus 50 degrees is 150 degrees, should equal to 180 degrees. Therefore, angle ABD equals 180 degrees minus 115, which equals to 65 degrees. So, angle ABD equals 65 degrees.
2a sub-question I. Find angle BAD. I will pause for the solution to 2a sub-question I.
2a sub-question III. We are to calculate the angle BAD. That is the angle over here. In 2a sub-question I, we found the angle ABD to be 65 degrees. Therefore, from triangle ABD, the sum of angles in that triangle should add up to 180 degrees. Therefore, 65 degrees plus 65 degrees plus angle BAD should equal to 180 degrees, or 130 degrees plus angle BAD should equal to 180 degrees, or angle BAD equals 180 degrees minus 130 degrees, which equals to 50 degrees. Therefore, angle BAD equals 50 degrees. Also, the angle ABR equals 50 degrees, and the angle ABR is alternate to the angle BAD. This implies that the angle BAD equals 50 degrees.
2a sub-question I. What type of triangle is triangle ABD? I will pause for the solution to 2a sub-question I.
2a sub-question IV. We are to identify triangle ABD. The base angles of triangle ABD are equal and equals to 65 degrees. This implies that triangle ABD is an isosceles triangle. So that's the solution to a sub-question IV.
2b. Using a ruler and a pair of compasses only, construct triangle XYZ, with YZ equals to 8 centimeters, angle XYZ equals to 60 degrees, and XY equals to 9 centimeters. I will pause for the solution to above.
2b. We have been given the magnitude of SZ to be equal to 8 centimeters. Angle SYZ to be equal to 60 degrees. and magnitude of SY to equal to 9 centimeters. We are to construct the triangle SYZ. I. We are to measure the angle YZS, and II. We are to find the magnitude of SZ. Below is a sketch of the triangle SYZ. We shall now construct the triangle SYZ. We shall start with the side SY, which equals 9 centimeters. We shall first construct a horizontal line. With the help of a ruler, we shall mark out the points S and Y 9 centimeters apart. We shall label the points S and Y. We shall now construct the angle 60 degrees to the line SY at the point Y. To do this, we shall open the compass to a convenient radius. Place the tip of the compass at Y and draw an arc to intersect the line SY. Maintaining the same radius, we shall place the compass at the point of intersection of the arc and the line SY and draw an arc to intersect the recently drawn arc. We shall draw a line through the point Y and the point of intersection of the two arcs. This line forms an angle of 60 degrees to the line SY. We are to locate the point Z on the 60-degree line. We have been given the magnitude of YZ to be equal to 8 centimeters. We shall therefore measure 8 centimeters using a compass and a ruler. We shall now place the tip of the compass at Y. Draw an arc to intersect the 60-degree line to the horizontal. We shall label the point of intersection as Z. With the points S, Y, Z of the triangle known, we shall bolden the sides of the triangle.
Measure 2b sub question I. Angle YZX. 2b sub question I. XZ.
We shall now measure the angle YZS. We shall measure the angle using a protractor. We shall place the point of intersection of the 90-degree line and the 180-degree line on the protractor at the point Z. We shall rotate the 180-degree line on the protractor to lie on the line SZ. As can be seen, the angle YZS is approximately equal to 66 degrees. We are to measure the side SZ. We shall measure the side SZ using a ruler. As can be seen, the magnitude of SZ is approximately equal to 8.5 centimeters.